Very good afternoon. Myself Dr. Ruchi Gupta, Associate Professor, IT Department. Today we will discuss a second phase of SDLC, that is software design. As we have already done the first phase of SDLC, that is software analysis and specification. Under that phase we have gathered the information from the user and other stakeholders of the company, and after collecting or gathering the information from the users, we have scrutinized that requirement, we have reviewed that requirement, and finally we have to prepare a document, and that document is called SRS. So SRS, it is a legal document between a customer and the developer, and once the company will prepare this SRS, then only we can insert into the next phase of SDLC, that is designing phase. So we can say that SRS is a input for the designing phase. So now after preparing the SRS, we will start the designing of the software. So if we are talking about the software design, it is more creative than analysis phase, because in the design phase we have to go for the actual implementation of the software, or we can say it is a problem solving activity, and we have to define that how we can develop the software in the design phase actually. While we have discussed about the SRS in the software analysis phase, that it always define that what the system will do, but the designing will define that how the software will implement or develop. And the final outcome of this design phase will be a software design document. So it is this software design document is an outcome of this design phase. Now we come on the definition of software designing. So software designing, it is a software engineering activity where the software requirements are analyzed in order to produce a description of internal structure and organization of the system that serve as the basic for its construction or coding. So we can say that designing is the medium or interface between the analysis phase and the coding phase. So once the requirements which we have analyzed from the analysis phase, these requirements are to be converted into the structure format of the software, and then we have to use this structure of the software for the coding. So as per the IEEE standard, it defines that software designing as both a process of defining the architecture component, interface and other characteristics of software components, or and it finally produces some output in the form of process. So another definition of software design is that it is a highly significant phase in the software development where designer plans that how a software system should be produced in order to make it functional, reliable and reasonably easy to understand, which is to be modified and maintained easily. And SRS tell about what the system does become an input to the design process, and design process which tells us that how a software system will work. So software designing, it involves to identify the components of the software, the inner working and their interface from the SRS. So we can say that in the software designing we have to break down the whole software into the number of components, or we can say the number of modules, and we create a structure of the software, and after that we will define the inner working of that component of those components. So SDD is also referred to as a software design description. Software design deals with transforming the customer requirement as described in the SRS document into a form of set of document. That document is called software design document, and that is suitable for the programming language. So that's why I already told you that it is a interface or medium between the analysis phase and the coding phase, because SRS, which has to be prepared in the analysis phase, it becomes the input for the design phase, and after using this SRS we have to create the structure of the software, and again prepare a software document that is called a software design document, and this design document is to be used by the coding phase. So this is a complete design framework that how we can take the information requirement from the analysis phase, how we the design has to be worked down. So these are the initial requirements, and we have to gather all these data requirement, analyze all these requirement, and then conceive a high level design. If there is a requirement, we have to refine these requirement, and then we have to validate the design against the requirement. And after refining the requirement, we also obtain the answer of the requirement questions if some requirements are missing. So we have to refine these and requirement, and again refine the design document, and finally once we have to complete this design document, then we can say that a particular design is to be completed. So as we have to see the scenario that designing, it may be divided into two parts as per the customer need or as per the developer need. So basically there are two parts of this design process. One is a conceptual design and another one is a technical design. So conceptual design, we can say it is a top level design, or it is it show the overview of the software, or we can say it define that what the software will do. And the technical design, it define the inner working of the software, and it defines that how the software may be implemented. So the conceptual design is to be prepared for the customer, and the technical design is to be prepared for the developer or the builder of the software. Because we know that customer is not a technical user, so we never give a technical document to the customer, and developer is ready to implement that software, so we'll give all the technical details to the developer. So as per the need, customer as well as developer, there are two type of documents has been prepared in the design phase. One is a conceptual design document and another one is a technical design document. Now, what is the difference between this conceptual design and technical design document? A conceptual design, it describes the system in a natural language understandable form, that is understandable by the customer, and it does not contain any technical jargon value, and it is independent of the implementation. Means we never give any technical information into the conceptual design. And if we are talking about this technical design, so by the contrast, the technical design, it describes the hardware configuration, software needs, communication interface, input, output, network architecture, their translation from the requirement to the solution as per the customer problem statement. So we can say that the technical design, it contain all the technical jargons that not include in the conceptual design. So that is a basic difference between conceptual design and technical design. Now, these are some set of questions that may arise at the time of conceptual designing, like where will the data come from, what will happen in the data in the system, how will the system look, what choices will be offered to the user, what is the timing of events, how will reports and screens look like. So, as seeing a set of questions, we can easily understand the software concept, but there will be no any technical values included in this conceptual design. But if we are talking about this technical design detail, so it contains some hardware information, software, communication interface. It contains the I/O of the system, software architecture, network architecture. Means, as we have seen this technical design details, it contains all the technical details related to the software, which is not included in the conceptual design. So this is the basic difference between a conceptual design and the technical design. Now, if we are talking about the characteristics of a good software design, so we can say that we have to consider some points or some features in our mind at the time of designing. So, so that good quality product will be delivered to the customer. So, good designing is the key successful of the final product. So, there are certain characteristics of good software designing. The first one is the correctness. So, our designing should be correctly implement all the functionality which is identified in the SRS. We have to define all these functionality in correctly in the designing. Understandability means a good design is easy to understand, means it is easy to understand and any user can easily identify the problem statement through this designing or the structure of the software through this designing process. It should be very efficient and finally it should be easily amendable, means if we want to change something then we can easily change. So, these are some characteristics of the good software designing. Now, if we are talking about the features of good designing, so we have also considered some points. We kept some point in our mind at the time of the designing of the software that it should be consistent and meaningful names for the various design components. Means when we have to define the components of the software, or we can say that we have to create the structure of the software into the number of components, and these components are basically called modules. So, we give a consistent and meaningful name as per the module division. Designing it should be modular, means we have create the structure of the software, we have to create the hierarchy of the software and we have to divide the whole software into the number of modules, and it is very efficiently if we have to decompose the software at the very depth level. So, the software will be very easy to implement. So, modularity is one of the major feature of the software designing. So, modularity means that it should clearly decompose a set of modules, means we have to divide the whole software into the number of modules in very depth form, and it should neatly arrange the modules in a hierarchy, for example, a tree-like structure. So, we have to decompose the software into a tree-like form and there will be a hierarchy of the modules from top to bottom. So, this is a tree structure hierarchy of the modules. This is a control module. These are some sub modules. Again, we have to, if there is a required, again we have to divide the these sub modules into another sub modules. So, we have to still decompose the software into a number of modules if there is a requirement. So, this is a tree structure hierarchy of the modules, or this is a tree structure hierarchy of the software. This is your main module. These are some sub modules. Again, they are sub modules and again they are sub modules. We can say this is a root module and these are the leaf modules. So, we have to decompose the whole software in a tree-like structure form, that is to be shown here. So, basically when we have to designing the software, so the designing may be done through the two ways. One is a top level design and second one is a low level design. So, in the top level design, it is also called a architectural design that describe that how the software is to be decomposed and organized into the component, as we have seen in the previous slide, that we have divided the whole software into the number of components. It is a part of top level designing. Now, we come on the detailed designing. It is also called a low level designing and it describes the specific behavior of the components. Means now we come on the inner working of the modules. We have to show the inner functioning of the modules, and the output of these process, it is a set of modules that record the major decision that have been taken. So these are basically two type of designing which we have created. One is a architectural design or top level design, and another one is a detailed design or low level design. Let's see one example of module decomposition or a software decomposition. This is an example of functional decomposition of library management system. So, for example, there is a main module of library, and we have decomposed this main module into sub modules. So, one module is a search module, transaction, update and reports. Again, we have to subdivide these sub modules into another sub modules. So, search module is divided into two modules, that is book and reader. Again, transaction is divided into two sub modules, that is issue and return. Similarly, update is divided into two sub modules, reader database and book database, and report is subdivided into two sub modules, that is fine or book. So, as per the requirement, as per the SRS requirement, we have to decompose the software into the n number of modules or n number of components, and it is a good designing features that we have maximizedly divide the software into the components so that coding can be easy. Now, these are some software design principles. One is a modularity or decomposition, second coupling and cohesion, third is a top and bottom level designing, fourth one is a design complexity, and last one is then abstraction. So, what is modularity? As I have already discussed the concept of modularity in detail, that modularity is achieved by dividing the whole software into a unique name and addressable components, and these components are called modules. So, as I have seen in the previous slide that the whole software is to be divided into n number of sub modules. So, this is a decomposition, or we can say it is a modularity of the software. So, the basic idea about the modular designing is to organize the complex or the large software into the very easy or distinct component. So, the basic idea of the modular design is to organize a complex system or a large program or a large software into a set of distinct components which are developed independently. Now, these modules are to be developed independently, and finally, they will collect it together to form a software. And modular system consists of well-defined managed unit with well-defined interface among the units. So, we have to create our interface, well-defined interface among the units, and software is decomposed of the software modules such that the change in one module has a minimal effect to other module. So, this factor is also considered at the time of designing, that we have to create a minimal, we have to create an interface in such a way that the one module has a minimal effect on the another module. When we have to design or decompose the software into the modules, so at that time we have to consider these things, that modularization is a necessary part, and the interface between these two modules, we minimize the interaction, so that if any time if we want to change in one particular module, then it can minimally affect to another module. Means if we have to change in this module, and if this module is to be totally dependent on another module, so we have completely changed this module also. So, we have to keep these things in the mind, that the dependency between two different modules should be minimum, and it should also be discussed these things, dependency of the modules in detail in the next lecture, that is called coupling and cohesion. So, we should keep all these things in the mind, that dependency between two or more than two modules should be minimum. This is a structure of the module. So suppose this is your one module, this is another module. These are the functions of the modules. So basically at the time of designing, we have to create the modules and convert these modules into the classes. And again we have to create a class diagram at the time of designing. And basically, as we have know that class contain three components. One part is a class name, second is a class attribute, and third one is a functions or methods of that class. So basically modules, it represent the classes, and classes contain the attributes and the functions which may declared private, public or protected. And similarly, all the modules contain some functions and they have retrieved the data from main module, and some global data base is there. So all the modules are to be access the data from the from this database. Now the properties of the modularity, it is a well-defined subsystem, means we have to divide the whole software into the subcomponent. There will be a specific purpose for the subdivision of the software, and we can separately compile and store in the library. And in the designing, module can use other modules also, means dependency is there, because without no dependency we never implement any software. But we should kept in the mind that dependency, it should be minimum. But we can't say that without dependency we can make a software. No, it is not possible. So modules use other modules also, and modules should be easier to use, to build, and similar from outside, from the inside. Now the goal of modular design, the development of modular designing structure is guided by the need for satisfying the designing criteria regarding the coupling of pair of modules. As I have already told you that we have show the dependency between the modules or within the modules. So we show that cohesion, complexity, reusability and coupling within the between the modules. So the goal of modular design is to reduce the level of coupling between modules and increase the level of cohesion within the module. So we have considered these points, that at the time of designing, the dependency between two or different modules, more than two modules, it should be minimum, and the dependency within the module, it should be maximum. Because if we have contain the dependency between two different module maximum, then if suppose at any time if there is a requirement of change in one module, then we can also change another module, because one module is totally dependent on another. Similarly, if we have to maintain the modularity within the module, so suppose if in the same module, if we have to declare the attributes or the functions publicly in a single class, then we can use all these components, all these functions or methods within a class repeatedly. So it is a dependency within the module, and coupling is the dependency between two different modules. So we have to consider all these points. So in the next lecture, we have discussed about the concept of this dependency, that is coupling and cohesion. So thank you very much.